So proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rockets' red glare, the bombs bursting gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave.
I'm excited about this gentleman coming to talk to us. We tried earlier, but as you can see, he's in uniform. He's an active duty Army captain. Got called down for a little bitty storm called Ian down in Florida to help out with that. So we rescheduled. He's here today. He's going to talk about something I think we're going to find very interesting, which is the mission of the Army Corps of Engineers, and also about some of the locks and dams on our western Pennsylvania river systems. He's also brought a few pictures of some of what he saw down in Florida in Hurricane Ian's aftermath that will give us a little idea of the powerfulness of that storm. As I said, he is a captain in the Army. He's active duty. He's a West Point graduate with a degree in industrial engineering. That's why he's in the Army Corps of Engineers. So without further ado, let's give Captain Robert Jolly an Army welcome. Hoo-ah!
Use this, or can everybody hear me okay? Is this working? All right. So before I begin, first I want to thank all of you for having me here today. I'm very excited to be here. I see a lot of hats and maybe an engineer castle back there. Do we have any veterans or people with military service in the room? I'm sure we do. Okay. Well, as we come up on Veterans Day, let me say thank you to all of you for your service, and to let you know we still got it. We're holding it strong for you guys who have done your time. So anyway, thank you so much for having me, Mark. Thank you so much. We'll go ahead and get started.
Turn that on. Oh, there's an on button.
It should be. I think I clicked it already. Okay. So yeah, just to introduce myself very briefly. I was born in Rock Hill, South Carolina, which is a suburb of Charlotte, North Carolina. My dad traveled a lot for business. This is a very brief story. I'll share it with you. And he brought home a VHS tape about West Point, and he said, "Son, you're going to watch this tape. You're going to write an essay about it. And if it's good enough, I'll take you to see it." I'd never even heard of West Point. Didn't want to go, but I knew it was in New York, and I wanted to see the city. So I wrote the essay. We go to West Point, and as soon as I stepped foot on that campus, I knew I wanted to go there. And so that's what I did. And I graduated in 2014, commissioned as a second lieutenant in the Engineer Regiment. And just as a little bit of a background, the Engineer Regiment in the Army is kind of broken into two chunks. You've got your tactical, crawl on the ground, shoot people side of the Engineer Regiment, and then you've got the Army Corps of Engineers, which is a whole other side. Some Army officers stay in the tactical side their whole career. Some kind of bounce back and forth like I have. So that's why you'll see some pretty dramatic changes in my career experience. My first duty assignment was with the 1st Infantry Division in Fort Riley, Kansas. I don't know if anybody had pleasure of going there. It's a great place. Deployed twice to Kuwait and to Poland. My second duty assignment after that was with the 249th Engineer Battalion, which is how I ultimately wound up here. That's a very unique formation in the Engineer Regiment. They do medium voltage electricity in austere conditions for the Army. That's base camps, radar systems, things like that. But for them to prepare to do that, they got to practice with civilian equipment, and so they help with hurricanes, and that's how I first got into this. So this picture is me as a company commander in Hawaii. That was my duty station. Before this, working with these two gentlemen here to figure out how to bring our very large generators to power the cranes in Honolulu Harbor in case a storm were to hit it. From there, my wife and I were determining where we were going to go next. And as we were sitting on the beach in Hawaii, we were like, what would be the best place to go next? And we said, Pittsburgh, Pennsylvania. And I actually mean that because she's from Johnstown originally, went to the University of Pittsburgh. She's got family here. And I didn't know this at the time, Pittsburgh, the district here, manages temporary power, which I had been doing for the Army otherwise. So we jumped on the opportunity, got married in Cape May this summer, and I've been serving with the Army Corps of Engineers in the Pittsburgh district ever since. And I'm also, for those of you who don't know, your neighbor. I live over in Edgeworth on the corner of Pine and Hazel. Love the community. This is a great place. I'm actually a member of this Y as well. So today what I came to talk to you about is what the Army Corps of Engineers is. And a step below that, for those of you familiar with military structures, you got your headquarters and you got your division, which ours is the lakes and rivers of the Great Lakes and the Ohio River systems. Below that, we have the Pittsburgh district itself, and then I'm going to talk about the disaster response to Hurricane Ian and Fiona, and then I'll be happy to take questions at the end. I should say before I begin, I'm here acting in an official capacity on, representing my commander, Colonel Adam Shikansky. So any questions, of course, I'm going to have to answer them in accordance with the Army's guidance on those things. So I'm not going to be expressing any of my personal opinions here, and I'll do the best I can to answer your questions. If you do have more specific questions, I've got people I can link you up with who can answer some more of those. The first thing they taught me in engineering was don't answer questions you don't know the answers to. So there are some specific, very technical people in the room who ask very hard questions. I may defer those if I don't know the answers exactly. Okay. All right, so the Army Corps of Engineers. Not many people know this, but the Army Corps of Engineers is one of the oldest institutions in the country. And June 14th, 1776, the Second Continental Congress appointed George Washington to be the commander of the Continental Army. And not 2 days later, he was up to his eyeballs in problems, and he needed an engineer to come help him out. So he appointed one, Colonel Gridley. He sent Colonel Gridley to Boston to help build the fortifications around the city to protect from British incursion. And Colonel Gridley, with the help of some Massachusetts farm boys, got that project done on time and on budget, and taught the British a very powerful lesson. Unfortunately, they built it on the wrong hill, but the Battle of Bunker Hill actually took place somewhere else, but we've gotten better since then. And not only have we gotten better, we've gotten bigger. So the Army Corps of Engineers now covers the entire continental United States. It covers Alaska, Hawaii, the islands. We have a district in Japan, we have a district in Korea, we have a district in the Middle East, and then also Europe as well. It's truly a global organization. So our divisions are these kind of major contiguous colors like the reds and the greens. Those are the divisions, and they're built around watersheds, major watersheds in the United States. Broken down from those divisions are the districts. If you can kind of see here, let me get my pointer. The Pittsburgh district right here is part of the Lakes and Rivers division, which we'll talk more about in a second. We also have the luxury of 9 centers and laboratories who do a lot of research into materials and construction techniques. You would think that our universities and some of our private sector industry could handle a lot of that research, but those centers and labs do expeditionary construction, like how do you build a bridge out of 2x4s in a combat zone, things like that that's not necessarily covered anywhere else, and they do really phenomenal work. Corps of Engineers is commanded by General Spellman, and his command sergeant major is Patrickson Toussaint. I don't know how many of you had military experience. If you ever got to meet your sergeant major, you probably know what they're like, and this guy is just like them. Very sharp, very mean, not the kind of guy you want to meet in a dark alley. I'll tell you that for sure. You can also see on this slide, there's one active Army unit. I told you about the 249th, that's the one that I was in, and how I wound up here in the Pittsburgh district. So the missions of the Army Corps of Engineers, they are everywhere, they do everything, and I learn more about it every single day. It has this major mission to build installations and military infrastructure. So on bases, air bases, they also do the Veterans Administration, all the hospitals, they build those. And anything overseas, the Army Corps of Engineers manages. They also do civil works, which is obviously very important to this region, especially. The civil works include the locks, the dams, the reservoirs, the flood control, hydropower, everything like that. The original mission, of course, of the Army Corps of Engineers was to provide inland navigation. We've maintained that ever since. But we also can do contingency operations, which is disaster response, any kind of major unexpected event. And the things that we've been involved in are truly phenomenal. For those of you who remember when COVID first started, the Corps of Engineers decided to build hospitals out of convention centers and hotel rooms, and they did that on the spot. They had some of our research guys down in Mississippi build internal hospital rooms out of containers, design it, send it around, and contractors were building that within 2 weeks. It was phenomenal. We also do a lot of geospatial support for maps, flood control, things of that nature. And then we also serve as the engineer for the federal government. So whatever the federal government needs in engineering, we do it. Okay. So a step below that is the Lakes and Rivers Division of the greater Ohio River Valley and then the Great Lakes, commanded by General Peoples, Colonel Broderick, and then Stephen Durrett is this lead civilian. The Army Corps of Engineers is unique in that it's largely a civilian organization. It is the Army Corps of Engineers, and it's led by green suiters like myself. The majority of the employees are civilians. And so the lead engineer is Stephen Durrett. We have one here in Pittsburgh as well. We'll talk about her. The Great Lakes and Rivers Division covers a very wide swath of the United States, managing mostly the Great Lakes, and then the water flows into the Mississippi River. Now we get to the good stuff. So this is the Pittsburgh district. Colonel Adam Chikansky is my commander. The deputy is Major Tabaki, and Lena Hawkins is our deputy district engineer. She's been in the district for a very long time and is a phenomenal resource to the community. She'll be stepping down, I think, in the next year to pursue other things before she retires. But as you can see, the district here is centered around the Monongahela River Basin, the Allegheny River Basin, the Beaver River Basin, and the Upper Ohio River Basin. And if you can see, it's kind of a small slide, but each of those little tick marks is a lock and dam along our rivers. And each of these blue words is a flood control project, like a lake or reservoir that we created with a dam. So our district is unique because we have these big rivers, of course, 328 miles of them, 23 locks and dams, 16 flood control projects. Those are the reservoirs, local flood reduction projects. We have over 100,000 acres of public lands, of which 5.3 million people visit annually. We have a repair and maintenance facility on Neville Island. I don't know how many of you are familiar with that. It's called PWARS, and I think it stands for, I shouldn't have started that. It's something, I'll get the, it's a unique acronym and I can't remember it all the time. I hope that I could off the top of my head, but we're not. In addition to that, of course, we are the lead district for temporary power, which is how I got here. And that's something that I didn't expect, but here in Pittsburgh, we're not usually hit by disasters of many kinds. So as a result, Pittsburgh does a lot of planning and management and oversight of disaster response because we're generally safe. And our piece of that pie is temporary power, which I will be able to talk more about as we go. So the district history, this region, of course, is very important to this nation, always has been. The British fought the French over it, we fought the British over it, then we fought the Indians over it, and then we fought Virginia over it. Everybody wants to control Pittsburgh, always has, because of these river systems. And because they're so important, Congress decided that we needed to do a better job of maintaining the navigable flow. Without our locks and dams, for those of you who didn't know, the river, you could walk across it without those locks and dams. And now we have a 9-foot channel depth all throughout the whole way, which is pretty impressive. But after the Civil War, the federal government also got involved in managing the Monongahela and the Allegheny rivers to make one giant system. Coincidentally, that happened around the same time as the industrial businesses started to come in, and that was really a key economic driver for the region to have those rivers. But what generally happens with the federal government is when bad things happen, they make fixes. So there's been a lot of floods in this area. I'm sure all of you are very familiar with the Johnstown flood and the aftermath of that. In brief, you can't build your own dam these days. The Army Corps of Engineers has got to bless off on it. And then I'm sure you all remember or know about the St. Patrick's Day flood itself, which gave us the ability to build the flood control dams elsewhere along the river, which is unique. This is not necessarily my specialty of engineering, and I've learned a lot about it since then. But the rivers themselves are maintained at a navigable depth with locks and dams, and the reservoirs control everything else. They make sure that the water don't have floods, and that there's not droughts that bring the channel too low. So after that flood, the first dam was Emsworth down I guess, yes, downriver, that's right, downriver from us, to raise the river level a little bit more. And we were instrumental during World War II, as many other industries were in this region, to build the material needed to win the war. In 1960, I thought this was interesting. We also were instrumental in constructing the Nike missile silos around Pittsburgh, which I think had been decommissioned, though I don't know for sure. And then in 1972, the Clean Water Act gave USAID the authority to regulate what goes into our streams and wetlands. So our district, again, this is more of a blown up map, has the locks and dams all along the Allegheny, Monongahela, and Allegheny rivers. And then these projects, you can kind of see in their scope and scale what all they do. And all of them are designed as one system to facilitate the flow of commerce in and out of Pittsburgh towards the Mississippi. So, why is river traffic important? I didn't know this. I come from South Carolina, we don't have river traffic there. It was never occurred to me that you could use the river for traffic. But as I've come to learn, not only is it more efficient, it's more environmentally friendly, and it's more effective. You can see here that a single barge, just one of those barges that you see floating by, excuse me, is 1,500 tons of whatever material. 15 of those barges together, which is generally what you see with one tugboat, is the same thing as a 100-car train, or excuse me, has twice the capacity of a 100-car train. One barge equals 15 jumbo rail hoppers or 58 trucks. And I think the best way to think about it is in terms of these miles. So like your general barge tow that's floating down the river has the same amount of supplies on it or product as 2 3/4 miles of train. And that's just one. And that's just a quarter mile. You see them going up and down the river all day long. It's an incredibly efficient way to move product. And as you can see over here, it's also, what did I do? It's also environmentally friendly because you're using less fuel to move more product. And so not only do these river systems provide us the ability to have an economic engine, it's a better economic engine for everybody. Now I kind of clicked ahead already, so maybe I gave it away, but does anybody in here want to take a guess at what the #1 commodity that we ship on our rivers is? Coal. What kind of coal? Yeah, so yeah, coal for thermal coal or for making steel. I think you got it correct. This graph here, there's a lot of data on it. I had to snip it off, so forgive me for the detail. But the circles represent the amount of commodity that goes through each one of our locks and dams, and it's broken down by what type. So as you can see, the light blue is thermal coal, and the yellow is the coal for steel. The major corridors, of course, go from the Monongahela up the Ohio and then out towards the Mississippi. You can see on the Allegheny there are locks and dams, but the traffic that goes through those dams is not very heavy for a variety of reasons. But as a result, the maintenance and the facility and the upgrades get driven by demand. So there isn't a whole lot of demand on the Allegheny River, so they don't get maintained as well. Because they're not maintained as well, there's no businesses that use them, and because there's no demand, it's a vicious cycle. The Monongahela in Ohio does get used, and so they're the ones getting maintained. And that's what we're going to talk primarily about today, is the major projects that we have underway on both Monongahela and the Ohio rivers. There is certainly a future for the Allegheny River system. It might just take a couple years or decades to reestablish that need. And especially with this cracker plant in Beaver County, as downstream industry proliferates, there may be more of a demand up the Allegheny as well if there's land for other industry uses. We'll see, you're right. Coal is the major shipping commodity through our rivers. I learned recently that Morgantown, West Virginia gets 100% of its electricity from coal-fired plants. And all of that coal goes down the river. To do maintenance on one of our locks and dams that would close the main chamber costs us so much of a backup, they've got to plan it a year in advance so that Morgantown can stock enough coal to run their electricity plants while they're doing maintenance on the lock and dams, because they won't be able to get coal barges through in time. So this is a very serious business, a very critical piece of infrastructure for our region. And before we go, so these graphs are hard to see, and I apologize, but this is almost a bar graph of the elevation changes. And I really like these because it shows here at Emsworth how the level of the river changes as you navigate the Allegheny River going up the mountain. I just think sailing boats or barges up a mountain is incredible. You know, the engineering feat that it takes to move a barge up a hill and then back down is incredible. And they do it all with gravity. There's no pumps, there's no electricity. They just open up pipes and they let the water flow in, and it's all gravity fed. Okay. Looks like my slide's not working. Hang on.
Middle one.
Say what?
Middle button.
Yes. Okay. That's all right. Back up. Give me 1 second. Okay, there it is. I had a notification pop up on my computer, that's what it was. So we have two major project areas going on in the Corps of Engineers right now, the lower Monongahela and the upper Ohio. And those are two major projects in our portfolio. And to demonstrate the value and effectiveness of the bipartisan infrastructure law that we just received, we can compare the lower Monongahela and the upper Ohio, because they were funded in different methods, and there were some great differences as a result. So the lower Monongahela has been a project that's been going on since 2004 to complete the upgrade to Braddock Lock and Dam. They replaced the fixed crest gate. For those of you who don't know, that means water just flows straight over the top. That's the fixed crest gate. And they replaced it with a full gated dam at Braddock. There is another fixed crest gated dam nearby at Dash Shields. For those of you familiar with that, it's very close by. And I would be remiss if I didn't take 1 second to pause here and say, for those of you with friends, family, with boats, or go out on the rivers, please be careful around Dash Shields Lock and Dam. You can't see it necessarily, but if you go over the top, which you can if you're not careful, you'll get caught in the backdraft, and people, at least one person dies almost every year doing that. They have these huge orange floating signs out there that say, don't go underneath this, please don't go underneath those. Because if you do and you go over the top, there's not a whole lot we can do to help you at that point. So please be careful around Dash Shields. The rest though have gates, and while are dangerous, are not quite as dangerous. So anyway, Braddock was replaced. The next step of this process is to remove Elizabeth Lock and Dam, because this is getting upgraded. They're going to remove Elizabeth Lock and Dam, and then they're going to improve Charleroi. You can kind of see the proposed changes, and they're already well underway with this construction to make both of these chambers much bigger. The barges today are much bigger than they were when these locks were originally designed, and towboats can push more of them, so these trains are coming in much larger. And so as a result, we need more capacity in these locks and dams to be able to push them through. And the biggest issue that we have is that while the main chambers work okay, when they go down for maintenance and we have to use the auxiliary to facilitate traffic, these barge tows have to go 2 barges at a time. So just picture this in your head. You've got 15 barges, 1 towboat on the downstream side. A towboat's got to take 2 or 3 barges in, float them up, take them off to the other side, tie them down, get back in the lock, go down, go to the other side, pick up 3 more. And he's got to do that until he gets all 15. And that's how they have to get through. It could take 6 or 8 hours to do a single barge tow. And that's nobody else, not our Corps of Engineer boats cutting in front of them. And there's a line. And so that causes an entire backlog along the entire river system, which is why it's so important to make these bigger locks and dam chambers so that we can continue to push flow when we're doing maintenance. But this process was funded kind of incrementally. They got funding for the planning, they got planning for some of the construction piecemeal, which has made it a little more difficult for us to plan and execute the entire Lower Monongahela project. As a result, like I said, it's taken longer and it's costing more money. We've had a lot of construction issues at Charleroi, but it's going to get done. It's just not quite as easy on us. As you can see, total project cost $1.23 billion, which is a major, major investment in the region. 90% funded, $958 million spent to date. Compare that to the Upper Ohio Navigation Project, which is the new big shining jewel in the Pittsburgh District's portfolio. This project was fully funded through what used to be called the Infrastructure and Jobs Act. It's now called the Bipartisan Infrastructure Law, they've told us. So hopefully I changed it on the slide. This is a recent change. But just in the same way, the Monongahela, they're going to replace the auxiliary chambers at Emsworth, Dash Shields, and Montgomery to the bigger chambers so that we can facilitate flow better to the Mississippi River from here. I didn't know this, but I learned that Montgomery Lock and Dam is like the choke point for the entire Ohio River. It's the smallest, least capacity one. And so that's why this project is so important. We had a huge industry day a couple months ago. Elected officials, union, industry, all came out there to celebrate getting the money to fix this lock and dam so that the entire river system becomes much more navigable and much more useful for all of them. Total project cost is going to be $1.8 billion, fully funded at the October 2020 price level. They've already started doing some preparatory work at Montgomery, some site conditions. They have to literally build their own concrete plant there. It's more efficient for them to clear out an area, build a concrete plant, and then just use a pipe to bring the concrete to the lock and dam as opposed to using trucks. It's an incredible process. It takes a very long time to plan and a very long time to construct. It'll probably be a decade's worth of effort to get that lock and dam complete, which is why having the money up front and knowing that we're going to do it helps us plan, helps us save money, and helps us get it done quicker. Because these locks and dams are part of a national system. And so, as you can see in this bottom picture here, the Ohio River, as it kind of winds its way, it goes through several districts on its way to the Mississippi. And so we all have to work together as a team to make sure that the entire river is navigable at all times. Like I said, this is a pretty incredible opportunity for the Pittsburgh district and in the region of Pittsburgh to enter into the 21st century and invest in itself for industrial growth. So highlights from this past year, we appropriated enough money to complete the design of Montgomery Lock and Dam and Emsworth, and then we awarded the contract for construction. To give you a perspective of what that's going to look like, this is what Charleroi looks like right now, or a couple weeks ago. It's hard to tell from this perspective, but this is 150 feet all the way to bedrock, and you're looking down on cranes lifting things. It's incredible. It's almost terrifying actually. But the amount of work that has been going into this lock and dam for the past decade it's really humbling. But this is how each of these new chambers will look when they're completed. So in addition to that, I said we hosted the industry day. People are very excited about the Montgomery Lock and Dam. They've hosted tours, they've hosted news crews. It'll be talked about probably ad nauseum for the next decade, so get ready for it. I'm letting you know now. We received a lot of extra money for operations and maintenance, which is great for us to take care of the backlog of maintenance issues that we have on our locks and dams to make sure they're safe and operating effectively. We had 3.5 million visitors to our recreational sites this past year, which is lower than it usually is. We're kind of coming out of COVID, but I think as people are getting back out into the world, they are coming more frequently, and that's great. I had no idea when I joined the Army that the Army had park rangers and parks, but they do, and they're all over here by their reservoirs. We had 51,000 commercial lockages last year with 173 million tons of cargo, which is incredible. And you can also lock yourself through in a rowboat or a bathtub if you want. You just got to have a life jacket and 75 feet of rope, and they'll lock you through, just no matter what. I've never tried that, but some people apparently have. Some people who float the whole river do it on some pretty unique watercrafts. There will be no judgment from our lock and dam operators. And what I'm most proud of, the Pittsburgh District's temporary power team completed $104 million in emergency response assignments. When I first started doing emergency response, it was just hurricanes. But now it's hurricanes, it's wildfires, it's tornadoes, it's anything. So we are very heavily and actively engaged in many local communities. I'm very thankful to do that. So why does the Corps of Engineers care about disaster response? And that's kind of a tricky question. Other than the federal government says so, Congress said so, but they said so because our job is inland navigation. And to provide inland navigation, We got to maintain water levels, which prevents floods. Floods are bad. Hurricanes cause floods. USAID handles hurricanes. That's kind of how the logic went. And so as a result, we do temporary power. We do urban search and rescue. We do temporary roofing. We maintain critical facilities. We can do emergency dredging, debris removal, or even temporary housing in the worst case scenarios. And we've done all of those at one point in time in just about every storm we've had in the past decade. And it's truly incredible. And it's not just the Army Corps of Engineers too. So we work very closely with our industry peers, our contracting partners, who do a lot of the legwork for us. My actual main job with the Pittsburgh district is to manage the resolicitation of our temporary power contract. So it's up for renewal. Every 5 years, we go back and we say, make some changes to our temporary power method, and we put it back out to industry to bid on it. And right now, we've had some really great lessons learned for the past couple of storms that we're going to able to incorporate to make this process more efficient and more effective with our industry peers. So as I said, I had the pleasure to go to Hurricanes Fiona and Ian, and again, I apologize for missing our original appointed date. Had it been anything else, I would have been there, but of course, Hurricane Ian kind of disrupted a lot of plans. But the Corps of Engineers was on ground before the storm even hit, especially for Hurricane Ian. I left on a Wednesday, flew to Montgomery, got in a truck, drove into Florida, worried that the storm was going to delay planes, and everybody else was already there. We sat down, let the storm hit us, and then we got immediately to work. It is a really impressive sight to see how well the federal government and the state governments work together in a disaster. The way this system's supposed to work, and when it works best, it does, is that the state manages everything. So we went to Florida, and Florida said, here's our priorities, here's what we can handle, here are the small things that we can't take care of. Federal government, can you do the rest? And we absolutely do that, but we wait on the state to tell us what to do because it's their response, their people. And that's how the federal disaster response system works. When we were in Florida, the state there gets hit with hurricanes pretty frequently, so they kind of know what they're doing. They didn't need a whole lot of help, but what they did need us to do was to take care of all the assisted living facilities in the affected region. So active duty Army soldiers, some of my old ones, when I was in command, they're the same guys, under a different commander now, but they were there at the same response, and they went to about every assisted living facility in the affected region to make sure that they had access to power. A lot of them, thankfully, were on commercial power and didn't need it. The main transmission lines didn't go down in Hurricane Ian, but there were some places that were very heavily devastated and had only a very small generator running their refrigerators for medications. A very terrifying situation, and so those places were the ones we would bring in these huge generators on the back of a truck. You can see the contract guy offloading it. It's their job to install it, maintain it, keep it running until commercial power is restored at those critical facilities. We had 4 teams there in Florida. We had another team in Puerto Rico at the exact same time doing the exact same thing, all happening at the same time. And it takes a lot of coordination and a lot of skill. And what I didn't know is that most of these people who do this, with the exception of me, because they tell me to, are volunteers. All the civilians who go down to do this guy right here, he's a volunteer. He might be a lock and dam operator or a park ranger, 99% of the time. Except when a hurricane hits, then he goes to respond. Like, these are not dedicated professionals by any case. They know what they're doing. They do this every year and they love it. But that's something they do in addition to their real jobs. They leave their families, they leave everything else they've got going on, and they stay there for as long as they need to. The team down in Puerto Rico was there. They actually might not have left yet. I think they are either leaving yesterday or they will be leaving in the next couple days. That's just to give you an idea of the scale. When those things hit, we stay in for the long term. After hurricanes Irma and Maria hit Puerto Rico, we were there for over a year, just to give you an idea. I had not joined by that point, so I didn't go to that one, but have been to many others. To give you a perspective of what all we accomplished during Hurricane Ian, again, like, there's a lot of data on this slide, and not all of it's one I'm familiar with, so we're not going to go through each and every piece of it. They installed 17,000 temporary roofs. We installed 12 generators in Hurricane Ian. They did 347 infrastructure assessments, provided 12 pumps to get water to reduce flooding. assess beaches. It's a truly impressive operation that they had going. And then Hurricane Fiona, again, which was happening at the exact same time, so the Corps of Engineers is managing both. And, oh, by the way, the Mississippi River is drying up, so they had that going on at the same time, too. It's shocking, the amount of things that they have to worry about on a given day. But they did 73 installations there and 265 assessments. And like I said, they should be hopefully leaving Puerto Rico soon. Okay, so at this point, are there any questions? I'm sure, yes.
Here, I'd like to.
Oh,
On these dams that you're replacing, are you using the sliding gates or the swing gates?
I don't know specifically the design plans. I think they're the sliding that go up and down.
Well, no, sliding gates are going from side to side, like the ones they're using down in Suez Canal and that. They replaced the old swing gates.
I'm not certain. All the dams that I'm familiar with have the gates that go up and down like this, and I'm not sure what their designs are for the new ones. I'm not familiar
Because,
with
the swing gates were all done gravity.
Right.
The sliding gates, I think you got to use some kind of power or something to get them in and then slide them out.
Are you talking about for the lock or for the...
In the locks.
Oh, okay. So, no, ours are the swing gates like this, and there are electric actuators that move the gates open and closed.
Okay, but are they still using swing gates or are they going
Yes,
to the
yes,
slides?
Yeah.
Okay.
Just for your information, PWARS is Pittsburgh Engineer Warehouse and Repair Station.
That's it, yeah. He knows. Were you there? Were you there? Did you work at PWARS?
council.
Oh, well, you know what you're talking about. You should have given this brief.
My question is, when does the Coast Guard come into play? Who actually operates the locks? Does the contractor operate the locks, and what role does the Coast Guard play, and what is your interaction with the Coast Guard?
So we operate the locks and dams. They're all our government employees who manage the locks and dams all day long to do the maintenance. The Coast Guard, we have very limited interaction with the Coast Guard. They do law enforcement things, and they regulate the ships, I guess, that are on the rivers. We don't do that part. So if there's infrastructure or buildings or docks along the riverways, that's us. What sails on it, I believe, if I'm not mistaken, that's the Coast Guard.
The Coast Guard inspects and authorizes the towboats and the amount of barges they can...
From my understanding, yes. And I think they're also looking at ways to make barges carry natural gas, which is one thing they currently cannot do based on, I guess, the guidance they have, which if they could, would be beneficial for the companies around here to be able to move natural gas via barge as opposed to truck or pipeline or rail.
Just for your information, and this is ancient history for you.
Okay.
We have a number of engineers that worked at Drouot Corporation back in the 60s and 70s that are members of this club, including myself.
Yeah.
Drouot built most of the locks and dams on the Ohio River, and the machinery and the gates were all fabricated right on Neville Island at our plant there. And after we were done with the Ohio River, the Corps did the same thing on the Arkansas River, and Drouot built most of those locks and dams and all the machinery that went with it. So, before you were born.
Yeah, well, thank you very much. They've held up really well. They have. We're just doing tweaks and maintenance. Thank you so much. Appreciate that. Yes.
Can you comment on the Mississippi River drying and the stranded barges and where that's going forward?
I know they're doing everything they can. Unfortunately, even if we were to increase the flow of the Ohio River from our reservoirs, what we need is rain, and unfortunately we have not had enough of it over the fall, late summer. I know they're doing emergency dredging to maintain the channel as best they can, and it is their job, and I know it's a very high priority, but that's all we can do.
What can happen in this district to mitigate the low levels in the Mississippi River right now? Is there coordination between you folks and the people in the Mississippi?
There absolutely is, and like I was saying, that we have some tools that we can use. We can lower the level of our reservoirs to push more water down the Ohio, but it would not substantially change the depth of the Mississippi enough to make it worth it for us. but it is managed at the national level. I think even Congress has to tell us when we can lower the levels in our reservoirs. It's that highly managed and controlled. But again, rain is the best case scenario. We just need more of it. Sorry. Okay.
How about hydroelectric power? Are you involved in that?
So we have, some of our locks and dams do have hydroelectric power. I'm not personally involved in that as much, but a lot of them are. Of course, not every river can accept a hydropower dam. They're not the right kind, and there are ecological concerns to putting them everywhere. So the places that can have it generally do, and the places that don't, there's usually a pretty good reason. But when we do have it, a lot of times we'll let a contractor run the actual hydropower plant, and we buy the electricity back from them, and they sell it everywhere else as well.
What's the average depth change when you go through the lock?
So on that last slide, I think it's like between 10 to 12 feet, something like that. It depends on where you are, and I don't want to speak exactly, but it is around that.
It seems like a lot of water being locked in and locked out.
Sure.
That you could get some power from if you had the right technology.
Right.
Just a thought.
Captain Jolly?
Yes.
A question. As everyone in this room knows, we had a major bridge collapse in Pittsburgh. I guess that was back in December 2021 or January. Somehow they were able to tear the bridge down, and now they've totally replaced this bridge within a year, which under normal circumstances would take probably 5 years. The cycle that you go through at some of these locks and dams that you're replacing, you indicated 10 years. Is there any way you could tighten up that schedule? Or is it a money issue, or why does a project take 10 years? I would assume Ray could tell us how Draveau built these locks in 12 months.
We didn't build them in 12 months.
24?
At least.
Okay, but it's a legitimate question.
No, it certainly is, yeah.
Money, okay.
Some of it's money, some of it's the scope and the scale and the amount of work they've got to do. A lot of it too is that these rivers are still being used right now, so there's still barges that we've got to float through, and so I think that's probably delayed some of the schedules. The numbers that I've given you, of course, are like our expectations, the benchmark that we want to beat and we intend to. And I think with the ability to plan ahead and use a single contractor instead of handing it back off and forth like we did at Charleroi, we should be able to get this done quicker. But we want to keep a realistic benchmark in place for a lot of uncertainty.
What is the staffing level of the Corps?
As far as our employees, well, if anybody's looking for a job, we have job openings. Go ahead, sorry.
I was just asking the number that are actual military versus how many civilian. Do you have that number?
Oh, not off the top of my head. I would say it's probably 99% civilian and 1% active duty.
And that number would be what?
So I think the entire Corps of Engineers is like 30 or 40,000 people. And so I think 4,000 might even be too much for the green suiters. It's a very small amount.
Speaking of traffic, I can remember years ago hearing an amazing statistic that Pittsburgh was actually the largest inland port in the country.
Yeah, it is, and I think it's the 20th largest port in the country of any port, like the coastal ones too. So yeah, the Port of Pittsburgh's huge. It's a great asset to the region. Yeah.
I got a question. On one of your slides, you were talking about how efficient transporting goods on the rivers are. Are we seeing an increase, or is it going down year by year based upon more trucks on the road and trains and so forth?
In terms of efficiency of the barges?
Well, no, it's terms of amount of cargo being moved versus years past.
Unfortunately, our friends in the rail and trucking industry are also our competitors for the river, so they have taken a lot of our cargo traffic because of the difficulties using the lock and dams before they're fixed and maintained. So we have started to see a decline in shipping volume, and there's a lot of reasons for that. Some good, maybe some not so much, but the idea behind these major projects is to revitalize those locks and dams so they are more viable to attract more shipping. The maintenance and repairs that are done on the locks and dams are normally funded by taxes from the shipping companies. And it's an unusual circumstance where they were begging for us to tax them more because they could not bring in enough money to do the locks, the repairs that they needed. They would pull in maybe $20 million a year or something like that. And if you want to do a $1 billion project, they've got to save for a very long time, in addition to the normal work they've got to do anyway. So they were begging for us to pull in money somehow, even from them. But instead we got the money to do the locks and dams from Congress.
We're hearing a lot of stories about how recruitment throughout the military is down for a variety of reasons. Are you guys in the same kettle?
Well, the Army Corps of Engineers as a whole, like I said, it's a lot of job openings and vacancies. The officers here that come to Pittsburgh, it's actually pretty great assignments. We are fully staffed for Army officers here. But the recruitment is a major issue. It absolutely is across the board. And I don't pretend to know how to solve that problem. I wish I could. But I hope as the wars in Iraq and Afghanistan, that era kind of changes and we refocus the Department of Defense toward other threats, that will attract a new generation of talent from high schools and other places like that. We'll see. Yes?
Are you done with the Emsworth Dam?
No, I don't think we've started it yet.
Oh, I thought they emptied the one channel out.
They may have. It's been a minute since I've been there.
I remember going as a kid down and watching the boats go through.
Any other questions? Anybody? All right, we'll wrap up a little early.
Oh, I'm sorry.
Captain Jolly, thank you very, very much. Appreciate it.